Studies in Medieval School of Astronomy and Mathematics of Kerala by Mahāmahopādhyāya, Professor P.C. Muraleemadhavan sir. I now invite Professor K. Yamuna ma'am, Head Department of Vyakarna and former Dean, Sri Shankaracharya University of Sanskrit, Kaladi, to formally welcome the participants of this session. Ma'am, over to you, please.
Thank you, Ashwati. Distinguished guests, respected professors, researchers, and dear students, good evening to all. Today's lecture series is being conducted under the MOU between University of Hyderabad and Sri Shankaracharya University of Sanskrit, Kaladi in Kerala. This series is dedicated to revisiting the richness of Indian wisdom. Today's session is titled Revisiting Indian Knowledge Systems, New Studies in the Medieval School of Astronomy and Mathematics of Kerala. We have honored to have Professor P.C. Muraleemadhavan sir delivering this lecture. He is a renowned scholar in the field of Sanskrit studies, widely recognized both in India and abroad. His following this lecture, and we welcome him with following this lecture, and we welcome him with deep respect. I also take this opportunity to welcome Dr. Achyutananda Mishra, also one of the coordinators of the MOU from Sri Shankaracharya University of Sanskrit, Kaladi. Dr. Mishra is a poet, speaker, and academician whose multifaceted contributions enrich our academic community. We are delighted to have him with us today. No university program is complete without the active participation of its researchers and students. This lecture series is being steered by the dedicated scholars of both Sri Shankaracharya University of Sanskrit, Kaldi, and University of Hyderabad. I extend a proud and warm welcome to all the researchers and students of University of Hyderabad and Sri Shankaracharya University of Sanskrit, Kaladi. Finally, I warmly welcome all the faculty members and academicians who are present here, both in person and online. With that, I invite Sri Maya C., Research Scholar, Department of Sanskrit Vyakarana, Sri Shankaracharya University of Sanskrit, Kaladi, to formally introduce Professor P.C. Muraleemadhavan sir and begin today's session. Thank you.
Good evening, everyone. Am I audible?
Yes, Maya.
Okay. It is my privilege to introduce our distinguished resource person for tonight, Mahāmahopādhyāya, Professor P.C. Muraleemadhavan Master, the recipient of Rashtrapati Puraskar for the lifetime contribution to Sanskrit in 2017. He completed its Masters in Sanskrit Sahitya from University of Madras in 1974, and later he earned his first PhD in Sanskrit Sahitya from Central Sanskrit University, New Delhi in 1987, followed by second PhD in Nyaya Shastra from University of Calicut in 1993. He served as a former professor and head of the Department of Sanskrit at Central Sanskrit University, Guruvayur campus, and later as a former professor and head of Sanskrit Sahitya at Sri Shankaracharya University of Sanskrit, Kaladi. Would you hear this? So he also held esteemed position of Director of Planning and Development. Beyond the university landscape, he has served as a former advisor to the Sahitya Academy for Sanskrit and former chairman of the Adarsh Sanskrit Vidyapida in Balasheri, and has offered his invaluable expertises to Chinmaya International Foundation Shod Sansthan in Piravam. He has produced the 13 doctoral degrees and has edited, translated, and commented on 25 authoritative books across English, Sanskrit, and Malayalam, and published more than 200 research articles. Among his kavyas, Brimgageetam, Ampashtavam, Kavi Bhaskaram, Naumi, which have been considered for several national awards. Furthermore, its masterly Sanskrit commentaries, including Rasika Ranjani, the commentary of Chadaka Sandesha, and Nikashopala, the commentary on Vyutpattivada Karika, have earned prestigious academic honors such as Malinada Puraskara and Vijayashri Award. Among his editor work, the facets of Indian culture and Indian theories of hermeneutics and effulgence of Indian wisdom and new horizons of ethological research need special mention. He has unearthed 18 unpublished Sanskrit works. As the very first regular teacher in Sanskrit Sahitya at Sri Shankaracharya University of Sanskrit, Kaladi, he stands as one of the foundational pillars who actively shaped the institution from its very inception. His academic brilliance has resonated globally, serving as a visiting professor and resource person across US, UK, Canada, Australia, Japan, Finland, Thailand, and Nepal. He has delivered many prestigious lectures and convened key sessions of World Sanskrit Conference in Australia, Finland, and Nepal. He has been honored with the highest academic title, Mahāmahopādhyāya, was conferred the prestigious Bharat Rashtrapati Puraskar by President of India. His contributions have been celebrated with numerous prestigious laurels, including the Parikshit Maharaj Memorial Award, Devi Prasadam Award, Bhasha Puraskar, Kalidasa Puraskar, Vijnana Peedam Award, Guruvayurappan Kirti Puraskar, Akshara Shloka Tilaka Award, Samskrita Vidya Bhaskara Award, Ashtavidya Guru Shrestha Puraskar. Since 2020, he has been the Director-in-Chief of the Kandalur Shala Institute for Higher Learning and Research in Ancient Indian Wisdom, Trivandrum. Thank you, sir.
Thank you, Maya. Before moving to the lecture, sir, unmuting.
Yes.
Uh, we have to share the screen. Are you okay with that?
Yeah, this is good.
Okay. So, thank you, Maya. And I'm deemed it to a privilege to invite Professor Muraleemadhavan sir to deliver today's lecture. Sir, may I request you to deliver your insightful lecture?
Thank you, Ashwati. Shruti Smriti Purananam Alayam Karunalayam Namami Bhagavat Pada Shankaram Loka Shankaram. Learned organizers of this great intellectual event, Professor J.S.R. Prasad, Head of the Department of Sanskrit Studies, University of Hyderabad, Professor K. Yamuna of University of Hyderabad and Shankaracharya University of Kaladi, teachers, researchers, and students of various universities now present in virtual platform. I salute you all with folded hands and bowed head. Really, it is a matter of great privilege for a person like me to get an invitation to deliver the inaugural lecture of a significant lecture series named Tadvidyasambhāṣā. Actually, that comes in Ashtadesha Sangraha, that Ashtadesha, that Sara Sangraha. This expression comes. I will speak about it later. And which has been envisaged, this lecture, as an intellectual feast by organizing universities, University of Hyderabad and Sri Shankaracharya University, Kaladi. This, I congratulate the organizers for naming this meaningful event, academic event, this lecture series titled Tadvidyasambhāṣā, which is given to this lecture series. This expression really comes in the chapter of Agriya Sangrahaniyam in Ashtanga Sangraha. It's a very, very beautiful and very meaningful name given to this lecture series. This great moment, the moment in the studies of Indian knowledge systems, initiated by Government of India, has been implemented. Actually, it is very fruitfully by a group of erudite scholars of IITs, IIMs, and NITs of our country in these 3 decades. This scholarly group, through their research-oriented academic exercises, brought out several novel and shining doctrines hidden in the classical Sanskrit Shastra texts of Vyakarana, Navyanyaya, Vedic Suktas, Ayurveda, Vastuvidya, Ganita, environmental studies, and the like. The process of regenerating Sanskrit Shastra studies in tune with modern scientific lines are made in vogue by these scholarly groups. The IKS project aims to bridge the tradition and modernity in all scientific fields to bring a kind of continuity that is Nairandarya in all these fields. We can bring this continuity for a better world only by a discriminative scientific approach. It is the discrimination of dead and living in our tradition. What is dead in our tradition? What is living in our tradition? In our tradition, we come across living and shining principles which make us authorities to move ahead in the modern scientific world. But we also come across some dead elements, the studies of which never favors our advancements in the present scenario. They are born out of those blind beliefs and customs and like that. They are born out of blind faiths and customs in our tradition. They should be disregarded or discarded. Grahya Tyajya Viveka is the essential quality of a research scholar, or rather has to be imbibed. As Mahakavi Kalidasa says, Purana Mityeva na sadhu sarvam nachapi kavyam navamitya avadyam sandha parikshya anyatagat bhajande mudha parapratyaya neya buddhi. The major issues in IKS projects faced in IITs and IIMs when they implement is the non-familiarity of Sanskrit language of the modern scientists, young scientists. Indian Shastras suffered a lot due to this non-familiarity, which was the net result of the colonial rule. It means this colonial rule cleverly removed Sanskrit language, rather marginalized the Sanskrit education from the mainstream of our country, education system of our country. The scientific inquiry and research in Sanskrit in Ayurveda, Ganita, Vastuvidya, etc. distorted to a great extent. The new education policies of Lord Macaulay created so many educationalists and scientists without any background of Sanskrit knowledge, rather Indian and Indian culture. The pressing need of the project of IKS is to bring back familiarity of Sanskrit language among young Indian scientists and researchers. There should be continuous dialogue between Sanskritists and scientists, which will open new vistas of interdisciplinary and multidisciplinary studies and research in ancient Sanskrit texts in our Indian knowledge systems. As the first phase, Government of India is planning to give directions, also decided to give directions to the leading scientific institutions like IITs, IIMs, and other significant national level significant institutions to implement in their curriculum previous provisions to conduct a bridge course in Sanskrit to enable the studies in Sanskrit texts by scientists, modern scientists. Now, our former Prime Minister, Professor Sri Jawaharlal Nehru, in his work, The Discovery of India, I quote, he said, I quote, "If I was asked what is the greatest treasure which India possesses and what is her richest heritage, I would answer unhesitatingly, it is the Sanskrit language and literature and all that it contains. This is a significant heritage, and so long as this endures and influences the life of our people, so long as the basic of India will continue. The knowledge of Sanskrit and through it, and knowledge of our entire intellectual, what we call heritage, is essential for an enlightened understanding of our modern technical age." Actually, what is science and what is technology? The word science in Latin means knowledge. Science has to be understood in its original meaning of knowledge. All knowledges can be named as science. And as such, it must include knowledge of both the outer nature and man's inner nature. This is the only antidote to the maladies afflicting mankind today. While science is the way of thinking, observing, and experimenting, technology is its offspring. In other words, we say that science knows and technology does. Today, when we talk of science, it includes also technology. Hence, we say that this is the age of science and technology. I wish to emphasize the science is an essential ingredient of Sanskrit. Actually, how our science is, the modern science is finding the solutions, remedies for the problems raised every day. Example, earthquakes are among the greatest natural hazards which kill thousands of people and render many more homeless and destroy properties worth crores of rupees. Unlike cyclones and floods, they occur all too sudden and before any precaution can be taken. In spite of the several advances claimed, modern science, which spends millions of dollars in research on earthquakes, is a helpless observer except for a postmortem after the event. It is in this context that one may be benefited by looking into the ancient Indian Vedic sciences for possible clues on this subject of predictive seismology. Interestingly, Varahamihira has devoted a chapter on the science of earthquakes in his monumental work titled Brihat Samhita. This work is accessible to the modern scientists also by the work of Mr. Ramakrishna Bhatt, which includes an English translation, notes, and literary comments on the original work of Varahamihira. India is known to be one of the most ancient sources of knowledge on metallurgy. Sanskrit literature is replete with extensive descriptions of metallurgical formations, functions of various alloys of basic metals as copper, zinc, iron, gold, and silver. Even more mysterious are the descriptions given in Vimana Shastra and aeronautics and rocketry text for various formulations for a large variety of alloys used in various parts and assemblies of the Vimana. Some formulations for alloys given in the Vimana Shastra have been tried out in the laboratory and found to be novel with interesting special properties and features. Some more alloys with the superalloys they call, properties described in the Vimana Shastra are yet to be deciphered and reproduced. It is noticed that several scientific aspects of computer software are embedded in Vedas and Shastras almost in the same form. The approach of the compilers in translating the statements of computer languages is found to closely follow the approach of Mimamsa in its Vakyartha Vichara. The key words in computer languages are similar to the Samakhya categories of words in the Veda. The urge of the programmer to instigate the computer through his program commands has total resemblance with what we call the Shabda Bhavana of Mimamsa. The concept of program unit is similar to Prakarana in Mimamsa. The main program matches with Mahaprakarana, while the sub-programs in computer matches with Avandara Prakarana. Several similarities are noticed between the computerized management system and Vidhi Vibhaga of Mimamsa. While the flowchart methodology of computer projects resembles the Utpatti Vidhi, the development of the application programs similar to Vinyoga Vidhi also, and the execution of computer programs matches with Prayoga Vidhi. So, Utpatti Vidhi, Vinyoga Vidhi, Prayoga Vidhi, Parvapari Vidhi, and like that, all Mimamsa, these Vidhis are very close to the computer the systems that we use nowadays. So, the Kramalakshana in Mimamsa has several similarities with the data structures of computer programs. In particular, the Paurvaparya in Mimamsa has the features of linear lists like queues and stacks of computer science. The concept of equal time slots in the time-sharing system of computers exactly matches with the equal time concept of Pravritti Krama. The concept of processing in computers with no delay in between steps matches with that of Avilamba of Prayoga Vidhi. The need for special privileges for attending special tasks is recognized in the form of passwords in computer environment. All these are in the Mimamsa text, Shastra. Similar concept is noticed in Vedic system also as given under Adhikara Vidhi. The possibility of occurrence of errors, that is also there in computer, in the formation of words and sentences is recognized in both the systems. The contribution of Sanskrit to the various branches of now, why I have given a detailed introduction to Indian knowledge systems, because several people, they are not familiar with what is, even Sanskrit people, we are not clear. We have no a clear picture. We have not have a clear picture how the Indian knowledge system works. What is its application? What are the shastras being studied? So that's why I have given the first part of my lecture, I have given a general introduction to this. Now I am coming to the subject mathematics. The contribution of mathematics, medieval school of mathematics in Kerala. The contributions of Sanskrit to the various branches of mathematics are admittedly of great significance. The decimal place value system, together with the zero, was perfected in India centuries ago. The earliest available record of the use of the zero is in Pingala's Chandas Sutras, that's roughly written in 200 BC. Modern scientists like Laplace and Einstein have praised India's contributions to mathematics sky high. Laplace has said, I quote, how grateful we should be to Indians who found the great decimal system, which does not occur to the minds of such mighty mathematicians as Archimedes and Apollonius. Albert Einstein has observed, I quote, we owe a lot to Hindu Indians who taught us how to count, without which no worthwhile scientific discovery could have been made. So now coming to the Kerala sector, the history of mathematical activity in Kerala can be broadly divided into two, as medieval period and modern times. Medieval period, sorry, 1 minute, I will just. One minute. Yes. The history of mathematical activity in Kerala can be broadly divided into two, as medieval period and modern times. Medieval period, for our present purpose, may be taken, as I told you, and be taken as extending from 13th century to 19th century, and the modern period extending up to the present times. During the last 50, 60 years, non-European roots of science are being traced, and the corresponding contribution thereof is being critically assessed. As regards mathematics, India has made a commendable contribution. The concept of zero that I have already told you, and starting with the Aryabhata, and ending with the Bhaskara II of Lilavati fame, belongs to 12th century. There has been a continuous and widespread mathematical activity all over India. This period may be called the classical period of Indian mathematics and mathematics and astronomy. Stalwarts like Bhaskara I, Brahmagupta and Mahavira came up with striking mathematical findings which were to be developed in the West centuries later. To cite a few such findings of one of these scholars was Brahmagupta, that is enunciation of different formula. Enunciation of the formula for finding the area of a cyclic quadrilateral as S minus A, S minus B, S minus C, S minus D, where A, B, C, and D are the sides and S the perimeter of the quadrilateral. Though Brahmagupta was the first man to give this formula, today this is known in the name of a Westerner, W. Snell, a European scholar of 17th century. Solution of the second degree intermediate equations of the types, that also one something.
I would like to inform everyone to please mute your audio. Yeah, sir, you can continue.
The second difference interpolation formula, which is now known as Newton-Stirling interpolation formula. This up to the 1950s, it was widely believed that no substantial mathematical work was carried out in India after Bhaskara II. But today, it has been widely accepted that mathematical activity of original and serious nature was carried out in some pockets of the country even after Bhaskara II. And Kerala's contribution is the most outstanding in the post-Bhaskaran era of Indian mathematics. Hence, the period extending from 13th to 19th century is called as Kerala period of Indian mathematics or astronomy, and this is called the medieval period of mathematics. Unique features of Indian mathematics. Now, before entering into the salient features of medieval Kerala mathematics, it would be better to notice some notable characteristics of Indian mathematical literature. In India, mathematics originated and developed as one of the three main branches of Jyotisha, the other two being astronomy and astrology. Jyotisha means all the three: Jyotisha, astrology, and astronomy. But in ancient India, Jyotisha meant mathematics, astronomy, and astrology. And the fact that predictive astrology, though not a science in the conventional sense of the term, has its basis on pure sciences like mathematics and astronomy, is often overlooked. This truth is often overlooked. As in many other ancient civilizations, in India also, mathematics and astronomy developed as twin disciplines. Just like our Indian darshanas, Sankhya Yoga, Nyaya Vaisheshika, Purva Mimamsa, Uttara Mimamsa, like that, all twin disciplines. And all the well-known mathematicians of ancient India, with a lone clear exception of Mahavira, were invariably astronomers. So mathematicians are also astronomers, and both the discipline has worked. And the Sulba Sutras and the Bhakshali manuscripts are the only two, that is Bhakshali, it is also Bhakshali, Dirgha is there, Bhakshali manuscripts are the only two ancient Indian works which deal exclusively with mathematics. Works and scholars of Kerala medieval period. Coming to the medieval Kerala mathematics, it has been widely accepted that in central Kerala, there has been a continuous mathematical activity extending from 13th to 17th or 18th century. And that this school of Kerala mathematics has made a commendable work in the field of mathematical analysis, study of infinite series, even 150 years before this branch originated in the West. Through this proposed project, there is a elaborated what we call course of action is happening in India as far as this medieval school of mathematics is concerned. Sangamagrama Mādhava, who might be called the father of Kerala mathematics, Padasheri Parameśvara, the profounder of Drggaṇita, Drg system of computation, Kalalur Nīlakaṇṭha Somayāji, the author of celebrated work Tantra Shastra Sangraha, Jyeṣṭhadeva, the author of famous work Yuktibhāṣā, Pudumana Somayāji, the author of Karana Paddhati, Narayana, the co-author of Kriya Kramakari, commentary on Leelavati. And he is a co-author. The other author is Tirukudaveli Shankaravariyar. And Shankaravarman, the author of Sadratnamala, are notable names in the Kerala School of Medieval Mathematics. The salient features of medieval Kerala mathematics. The first one is Aryabhatan system and Kerala mathematics. All of them were staunch followers of Aryabhatan system of computation. That is why we claim that Aryabhata belongs to Kerala, even though we have no sound proof to prove that he belongs to Kerala. But all Kerala mathematicians, they followed Aryabhatan system. In this connection, it may be noted that a major chunk of manuscripts of the text Aryabhatiya are unearthed from Kerala. That is also one reason. In other parts of India, Aryabhata system was not followed. They followed Surya-Siddhanta, was more popular than Aryabhatiya. Seldom they depend on Aryabhatiya also, but mostly it is another text called Surya-Siddhanta. Kadapayadi system of numeral notation. In ancient India, there were three systems of verbal notation of numerals. Verbal notation of numerals. For easy memorizing and recollection, versified language is more convenient. In Shastra texts, we have seen karikas in sloka form, versified form. That is more easy to memorize. So, for versification of numbers, three systems were used in Kerala. They are in versified form, and three systems are used in Kerala. The first two systems use letters of Sanskrit alphabet for numeral notations, just like Kadapayati. I will come later on that topic. So this Sanskrit alphabet for numeral notations. Bhuta Sankhya system used mythological concepts to represent the numerals by things associated with the number. For example, 4. When you say 4, Veda. When you say Veda, it is 4, number 4. And when you speak 6, it is Shaddarshana. Shaddarshana, if I use, it is 6. And like that, not Shaddarshana, Darshana commonly when we use. And even Samudra, when you say, it is 7. And like that, the mythological, that what we call system, the concepts are used to represent numerals by things associated with the number. Aryabhatan system was used only by Aryabhata, and no followers are seen. It is a difficult one, that is why. The earliest of the three, that is Kadapayadi system, in this system, numbers are represented by meaningful, catchy phrases and passages. Like Matpattur Narayana Bhatta has used Ayurarogya Saukhyam. And like that, people use in Matpattur Narayana Bhatta, you can see several, he is a master of this Kadapayadi system and used it very effectively. And for example, to mention the Malayalam era, 1111, 1111, all one. Punyapaga is the word used. Like that. So many, this is just an example I have given. In this system, numbers are represented by meaningful, catchy phrases and passages. Example, the E, as I told you recently. Now, the continuity of tradition in medieval school, a major characteristic of ancient Indian tradition is its oral transmittance. Hence, break of tradition may cause a heavy loss. In medieval Kerala, there was a teacher discipline continuity of tradition that has preserved many of mathematical findings of Sangamagrama Mādhava, which would have been lost but for this continuity. If this continuity was not there, it would have lost. Mādhava had given the value of as different infinite series. In fact, he is the father of Kerala School of Mathematical Analysis. His findings are recorded by later scholars in the tradition, like Kalalur, Nīlakaṇṭha Somayāji, Jyeṣṭhadeva, Pudumana Somayāji, and Narayana. These are the four major. There are some other scholars also. They are not very much significant. But these four are very much significant. They used the system of Sangamagrama Mādhava very effectively. Only two of Madhava's works have come to us. But several his works were being referred in other works. But the concerned work we could not unearth up to this time. So these two works of Sangamagrama Mādhava unearthed, they are Venuaroha and Sphuta Chandrapti. These are the two works. Periodical revision of computation system, rational and critical approach. Most important feature of medieval Kerala mathematicians is their rational and critical approach. Unlike the mathematicians of classical period, these scholars took pains to put in record the rationales behind their findings. K.V. Sharma, who has unearthed, published, and studied many of the mathematical literature of Kerala, points out that K.V. Sharma points out that many Kerala works have the sole purpose of showing the rationales, like Jyeṣṭhadeva, a Malayalam work of 17th century, is the best example. Written in the old Malayalam, it has Nīlakaṇṭha Somayāji's Tantra Sangraha as its basis. The work has preserved for us the mental working process. In Malayalam, we use Manakanak. That is mental working process of a medieval Kerala mathematician. The text is yet to be analytically and critically assessed. Experimentation, verification, and periodical revision. Coming to astronomical side, Keralites believed and pronounced clearly that astronomy is a science subject to experimentation. Is a science subject to experimentation. It is continuous verification and periodical revision. These are very badly needed for a Shastra. The Aryabhatan system of computation was revised here within 200 years of its inception. In the year 683 AD, it was proclaimed in Kerala that Aryabhatan system of calculation did not tally with observed data, and hence a modified system was promulgated. It is known by the name Parahitā. Again, Parahitā was discarded and a new revised system, Drggaṇita, that is Drg system, was implemented. This was enunciated by Vadasheri Parameśvara through his work Drggaṇita. The name of the work is Drggaṇita. Parameśvara observed eclipses, the most convenient phenomena to verify and the accuracy of a system of computation for a continuous period of 55 years. It was a tapas for him, a great penance. 55 years he continuously watched. He has also recorded the collected data in his Siddhanta Deepika, the commentary on Govinda Swami's Mahabhaskariya Bhashya. And his Drggaṇita is the product of this penance, like a research work. He starts, I omit some portion to save the time. Planets computed by Parahitā system are found to differ from their observed positions. In the science, however, it is stressed that observed positions are true positions. Planetary positions are the lone means of ascertaining prescribed time of rituals, and the time reckoned by incorrect planetary positions will not naturally be the right one. Hence, Dvidyas who have mastered spherics should strive for ascertaining the planetary positions. There are some slokas quoted, but I am omitting that. This great researcher, this Parameśvara, has also written profusely on astronomy. Besides writing commentaries on classical texts like Aryabhatiya, Mahabhaskariya, and Leelavati, etc., he has penned many original treatises. The next scholar, Nīlakaṇṭha Somayāji, discipline, the student of Parameśvara, Parameśvara's son, is his teacher, again brings in another revision through his Tantra Sangraha. This work dealing comprehensively with mathematics and astronomy and is an epoch-making work. And it is an epoch-making work. Besides recording mathematical findings which were otherwise orally transmitted, the author has explained the rationales behind such findings in this work. Somayāji, well known for his extensive and elaborate commentary on Aryabhatiya, has authored a small text called Jyotirmīmāṃsa by name, with the sole purpose of stressing the fact that the astronomy is a science subject to verification and periodical revision. So verification and revision, that should be a continuous process, and this astronomy is a science of that kind. Mathematical analysis, a method of integration based on subtle geometrical analysis and ingenious methods of summing up the series used to get infinite series for pi, sine that sine and cos and cosine, so to say, and the arc. All these. The most important achievement of this period, this has been recorded in this geometry in ancient India and medieval India, authored by T.A. Saraswati Amma. So, thus this medieval Kerala school of mathematics anticipated many of the later findings in the field. Most notable are the theorems, Taylor series of the sine and cosine functions, Newton's power series for the sine and cosine, Gregory, the famous series for inverse tangent, then Leibniz power series of pi for pi. All these series were developed by Sangamagrama Mādhava, who mentioned earlier, in Kerala in the 14th century itself. Now, when we try to sum up, we stumble upon two questions. Why this tradition came to an abrupt end? Why this solid contribution has not been properly studied and assessed? The onslaught of Western education systems and impact of colonialism may be put forth as a prima facie simple answer, but a deep study of social and cultural history of scientific tradition of India in general, with a special focus on this particular period, may be carried out for a better analysis of the problem. And a critical study of historiography of Indian mathematics, science and technology in ancient and medieval India should be carried out. And to invite and focus and a critical study of the historiography of the mathematics and the technology in ancient and medieval India should be carried out. And to invite and focus the attention of scholars to such indigenous scientific traditions. Serious seminars on social, cultural, and scientific aspects of traditional wisdom should be organized at various levels. Along with these, I want to give some suggestions how to work on this, on such subjects, not only in mathematics or astronomy. When you speak about Indian knowledge systems, the Indian Shastra texts especially, a history of science should be rewritten with a fuller and deeper study of non-European roots of science and mathematics. European roots we know. We should know what are the non-European roots. History of mathematical and scientific tradition should be included in the syllabi of not only in the history and Sanskrit courses, but also in the syllabi of technical courses like engineering, etc. Third, the history students should be taught Sanskrit with a different perspective. Sanskrit students should be made to pay more attention to mathematical and scientific and technical literature. They should be given a general picture of modern mathematics, science and technology and their history. So, Kerala Medieval School of Mathematics, going back to the original mathematical text in Sanskrit, it is now well known that Kerala was the pioneer of mathematical activities in India during the medieval period, that is 13th to 19th century. For the last, actually I have mentioned only 5 or 6 great legends in this field, mostly dominating Sangama Grama Mādhava, Patasheri Parameśvara, and Nīlakaṇṭha Somayāji, and like that. Some few I have done, but there are hundreds of. We have prepared a list in which more than 200 texts are being written in this period. So it is well known that Kerala was the pioneer of mathematical activities in India during the medieval period. For the last 6 or 7 decades, scholars of mathematics and history have been working on the Kerala School of Mathematics. See, as I mentioned, Professor K.V. Sharma was the pioneer from Kerala, who was the director, professor in the Hoshiapur. He was the man behind what we call unearthing so many valuable manuscripts related to mathematics, Ganita, and astronomy and astrology and like that. Apart from that, there are some other fields of sciences also. He has unearthed several manuscripts. We have Dr. K. Kunjundaraja also worked in this field, and he has contributed a lot in that. And now, at present, Professor N.K. Sundareswaran, who is formerly the professor of Calicut University, his PhD thesis is based on medieval mathematics of Kerala. And he is still working in several related texts after his retirement. And there are several people like Unnikishan, Dr. Unnikishan Tekepat, Dr. Lily Chako, so many people. Recently, in Trichur and around in the suburb areas of Trichur, we have 4 or 5 centers for study, for doing what we call for doing research and for higher studies in the medieval school of mathematics, mainly championed by Sangama Grama Mādhava. So in Trichur, in Central Sanskrit University, they have a department center for that. There is a Christ College there, they have a center. St. Joseph's College, they have a center. And likewise, even private organizations also, institutions also came up to take up this issue. So there is a great awakeness is being experienced among heralds regarding the what we call the regeneration of our ancient Sanskrit mathematical texts, exploring further in the manuscript material and go further and bring revisions. And as I told you, I have discussed all those things up to this time to bring this. So with these observations, because it's only 40 minutes given to me, I think it is crossed now. Anyway, I beg to remain. I request the organizers of both universities, Hyderabad University and Shankaracharya University, to go further in these areas. And we have materials now. We have unearthed several manuscripts now. Kandalur Shala Research Institute in Trivandrum, we have a great project for that. And we are working on a central project on medieval. There are so many things to be unearthed. Only a tip of the iceberg is visible now. The other things remain under the water. Only a tip of iceberg is visible. So many materials are available, especially related to astronomy, mathematics, and astrology. Astrology means I am talking about a Siddhanta Jyotisha, not what we call professing and like not like that. So with this request, I conclude my talk. I beg to remain. I thank the organizers for giving me this great opportunity to deliver a talk on this. It's a great, it is an ocean, and we cannot talk with 40 minutes or 50 minutes. I have mostly, I left some 15 pages from my written document paper because due to the paucity of time. So anyway, I also thank research scholars, those who have initiated to materialize this program, Ashwati and Krishnashri Babu, for giving their valuable time to organize such a serious academic event. Thank you.
Thank you, sir. Thank you for such an illuminating lecture. As a Keralite, I also feel like very proud and very grateful for as a part of this lecture. And now we are moving into question and answer section. Sir, can you please mute your video? Yes, thank you. So we will now open the floor for questions. In the interest of time, we will be taking only 3 questions from the audience. For those who have further questions, I request you to please write to us at iks@uohyd.ac.in. I'm going to share the mail in the chat box for your reference. Every question will be duly attended to. So I think, sir, can we take up few questions? Sir, unmute it. So can we go forward, sir? Sorry, sir, your audio is muted.
Yes.
Yes. So now only 3 questions are allowed from the audience. Anyone can. Is there any doubts? Is there any content you want to discuss? Anything?
Sir, how will you define this Indian knowledge system? Sometimes I hate to define this. I know that it's not only a single discipline. From a single discipline, we can understand Indian knowledge system. Let me tell you an example that when we taking this Kadavayani, it requires the knowledge of many disciplines such as the scripts, even it is Indian appomattox, everything. So it is highly interconnected. So how it's possible, sir? Sometimes I can't even define. Would you help me to define Indian knowledge system?
No. A very, very, very good question. Very, very sensible question. Actually, in India, we have started the practice of what we call disciplinary approach to the subjects we study. That is there. Only recently, the interdisciplinary, multidisciplinary studies are being brought in European scenario. But in India, if you want to study Sahitya, you should know Nyaya, you should know Vyakarana, you should know Vedanta. Without knowing Vedanta, how you can interpret the Rasa theory? Without knowing Nyaya, how you can discuss Rasa theory? So, everything, every subject is interrelated, and a holistic approach is required in all systems. Katamayadi is only a minor example, but when you go deep, dwell deep in the subject, especially the traditional shastras, you require the support of several other disciplines. And I will tell you a very beautiful sloka written by Abhinavagupta. That sloka is like this: Urdhordhva Maruhya Yada Arthatatvam Dhi Pashyadi Shrantim Avedayandi Bhalam Tadadyai Parikalpidanam Viveka Sopana Parambarana. This is the first example, what we can what we call a solid example, what we can give from Abhinavagupta's side. That he says that you cannot depend upon one. Bhattacharya also says, what is that famous verse in Vakyapatiya? Katham va shaktu munnedum swatarkam anuthavata. So, pratnya vivekam labhate. Pratnya vivekam labhate bhinnai ragama darshanaihi. Kiyadva shakyam unnedum swatarkam anuthavata. So, without one discipline, you cannot survive in the world. Even when you go to an office to work on computer, you should know so many other things. So, especially in our Indian tradition, we come across a very healthy interdisciplinary and multidisciplinary system of studying the subjects that is can be, for example, in Sahitya, somebody has mic has opened, I think.
Maya, can you please? Yeah.
So, if you want to teach Rasa Gangadhara, you should know Nyaya, you should know Vyakarana. And in Vyakarana text also, in Vedanta text also, you have to. See, in Vedanta text, if you want to teach Sankara Bhashya without knowing Nyaya, because his main opponent is Nayayika, Sankhya-kara, and like that, Bauddha. Bauddha is a vehement opponent to Shankara. So, without knowing those things, how you can read the Purva-paksha and understand what is the question, the sense. So, these are the things what we are happening. This is the characteristics of Indian studies, traditional Indian studies, especially in Sanskrit. Not only in Sanskrit, in other areas also we can see in India. In Tamil also you can see all these things. Yeah. So, in Indian tradition, whether you speak about Sanskrit tradition or Dravidian tradition or some other tradition, you can very well trace out the multidisciplinary approach in studying subjects. So that is without saying it happens.
Sir, but when we study a Veda, we know that there are 6 auxiliary, 6 Vedanga should be learned. And even if we are analyzing a text on the Nyaya or the Mimamsa or whatever it is, they have their own methodology to read the text. But when we approach into an Indian knowledge system, we don't know which are the disciplines to be intermingled in there. So how can
actually that because this discipline has developed now as known as Indian knowledge system. Previously, we never talked like Indian knowledge system and like that. So we study Vedanta, we study Nyayakarana, we study Nyaya. Normally,
their own methodology and their own procedure.
See, for that, interdisciplinary methodology has to be created. Methodology is nothing but a codified common sense.
Okay.
Methodology is quickly. You can work in Sahitya in one methodology, you can work in with another methodology in Sahitya. It should be systematic.
Okay.
It should be systematic, it should be scientific. Then only you will reach the destination. That's all. It doesn't mean that there is a well-written methodology, documented methodology, and all should follow that methodology. So that's why I told that methodology is nothing but a codified common sense. A researcher should have a common sense to do the work in that. They can deviate from the famous path of the methodologies, what we call followed by our teachers or our ancestors. We can create our own and do it. But here, your question regarding Indian knowledge systems, when you study, you have to study so many other disciplines. So there you require an interdisciplinary methodology is required. That you can frame, or rather a group of scholars can frame it and do it. No doubt about it.
Thank you, sir.
Thank you.
Thank you, Maya, for the question, and thank you, sir, for your time also. And two more questions we can ask. We have chance for 2 more questions. Anyone?
Namaste. I'm Dr. Suraj R.
Oh, namaskar.
Namaste, sir. Okay.
Yeah.
I'm Dr. Suraj. I have worked on Kerala School of Mathematics. My PhD was on that subject.
Okay.
I was
Very
really
good.
wondering. I was really wondering after hearing your presentation. Within 1 hour, it's very difficult to explain the entire Kerala School of Mathematics. But in due time, you have explained every aspect. And I have something to add. I think the Kerala School of Mathematics was started from the 4th century CE by the Varuji. So I think you have missed a few scholars, Varuji and Shankara Narayana. I think it is due to lack of time you have missed about 81 scholars and about 350 independent works and commentaries were there.
So
I think
actually,
it's very difficult to include everything in this short presentation.
Actually, it is
Okay, sir. Okay, continue, sir.
Paucity of time. I could not cover all the things. I have already admitted that and told that if we have a series of lectures, we can each 1 or 2 scholars can be dealt with in a day, and 1 hour or 2 or 1.5 hours like that. But here, Vararuji, it starts from Vararuji is around about 300 AD, and next comes Aryabhadan, that is Aryabhata, that is at 450 AD. Then Haridatta comes, then Bhaskara comes, Shankara Narayana, Talakkulat Govinda Bhattatiri, Sangamagrama Madhava, already I mentioned, Vadasheri Parameśvara also I mentioned, Pudumana Somayāji, Vadasheri Damodara is another very important, and Nīlakaṇṭha Somayāji. Actually, I could not get time to speak about him. He is about in 1400. Nīlakaṇṭha Somayāji also 1400. Jyeṣṭhadeva, another great scholar, I mentioned his name. He belongs to 1500. Mahishamangalam Shankaran is also there, and Kalalur Shankaranarayanan. And another great scholar in 1500, roundabout at that time, 1450 to 1500, that is Trikkunaveli Shankara Warrior and Trikkandiur Achyuta Pisharadi. Achyuta Pisharadi is a contemporary of Mathpatur Narayana Bhatta. So there are several people, and I think we need a series of lectures to introduce all these people and their contributions, and to the what extent they have done their serious research in all these fields. And then only we can mention or have further study in those manuscripts, in those texts. So this problem is there. But it is, what I have done is, I have taken some 5 or 6 major people, and based on that I have given this, and I have mentioned that there are several other scholars equally important and also not that much significant. Such scholars also there, but even then their works are very prominent. Even though they have not written much, they have small dissertations, small what we call monographs they have written, but they give much enlightenment in the field. So that is there. So that is there. What I accept that, but at the same time, we have no much time to even to mention the name. There is no time. Then what to speak about their works? Okay, Suraj.
Okay. Yeah. Okay. So okay. Thank you.
Thank you, Dr. Suraj. Anyone? One more question. So I think we can move forward
Yes.
if nobody is there. So thank you once again. Thank you, Professor Muraleemadhavan sir, for your generous responses. Now it's time to invite Professor Jyeṣṭhadeva Prasad sir, Head Department of Sanskrit Studies, University of Hyderabad, for his remarks.
Thank you very much, sir, for this wonderful enlightenment on the contributions of Kerala School of Mathematics.
Thank you.
As from the interactions, as all of us understood, it is not even a drop in the ocean of the contributions by the Kerala scholars towards mathematics. You have mentioned different names, and essentially you have classified these two periods, 13th to 19th century, then 19 onwards, modern period, two periods.
Yeah.
And starting from Mādhava, I think who was famous for talking about the sine tables, even calculating the and the calculus. I'm very much novice in mathematics. I only know for namesake. That is why I can only say that this lecture really motivated the young students, research scholars, further in the direction of case. Essentially, you talked about the interesting aspects of correlation between Mīmāṅsa and computer science from the IKS perspective, which is very interesting. You talked about flowchart, you talked about programming, you talked about data structures, compared with Utpatti Vidhi, Vinyoga Vidhi, Prayoga Vidhi. All this really, I remember long back, maybe 20 years back, Dr. R.V.S.S. Savadhanulu in Hyderabad wrote Mīmāṅsa and Computers.
Yes.
Also a Vedic scholar. Like this, there are some sporadic efforts by scholars, as you said, right? One aspect of the IKS itself is under the sun. That is IKS, because Bharatiyam Shastram Ati Vipulam Asti. Kalokiyam Naravadhi Vipalacha Prithvi. So that way, this really given a wonderful motivation and remarks about for the audience not aware of this. And you talked about decimal system, number system, starting from Pingala. Then when it comes to the Indian mathematics side, you spoken about Bhatta, Bhaskara. And essentially you spoke about Newton Stirling formula. This is very interesting because the Western scholars always allege that you don't have any specific contributions in Indian mathematics. Okay, not only in mathematics, in science broadly, especially in mathematics also. But I read an article long back. I don't know whether it is true or not, but I pray it must be true. It is something like the Pythagoras theorem, which is popular, that actually Mādhava has spoken about. This actually, there is no person existing in the name of Pythagoras. This is a cooked up story. A fictitious character has been, portrayed at a society like Pythagoras, and he is the one who invented this, discovered this formula. Like this, several places, I think we have the proof, because from Vedas onwards, we have this wonderful insights and leads towards Indian mathematics. I think in Chandogya Upanishad, there is a debate, discussion between Sanat Kumara and Narada. So there, as part of the Vidyas that should be learned, mentions Rashi Vidya. Rashi Vidya is Anka Vidya. Anka Vidya is Ganitam. So Taittiriya several types of numerals, starting from Eka, all this Eka Jame, this Chame. In this mantra, I've seen a very interesting discovery in Sripada Srivallabha Charitamrtam, otherwise known as Guru Charitra. Eka Chame, that is number one. And Tisra Chame, 1 plus 3 becomes 4, and this can be divided by 2. The Vargamulam becomes 2. Then comes Panchachame, 4 plus 5. 4 is already with us. I'm adding 5 more. It becomes 9. And the Vargamulam is 3. 3 into 3. Like this, a wonderful calculation has been found in this spiritual text called Sripada Charitamrtam. So, from Vedas onwards, several texts talked about the history of mathematics, and the entire world knows that 0 is a contribution from India. That way, the accusations or the allegations cannot withstand, because we have all evidences, historical evidences, and many more manuscripts are lying in the repositories which need to be explored further by young scholars, as our young scholars. I think Maya was talking about methodology and how it can be related to IKS. You have excellently answered the question. I would like to just add one more thing. With regard to methodology, yes, we don't have a text on methodology, but definitely we can compile different aspects and concepts of methodology from Sanskrit texts. What I meant to say is, what if I talk about Tantra Yukti? What I talk about Tantra Guna, Tantra Dosha, Ardhashaya, Arthakalpana, Sangati, 6 types of Sangatis, 3 in Mimamsa, 6 in Nyaya, Anubandha Chatushtayam, Uddesha Lakshana Pariksha, Shadvita Tatparya Linga, Laukika Nyayas. These are all part and parcel of the same methodology. I think India has in this book, it is wonderfully mentioned about the methodological aspects in Panini Ashtadhyayi. He did not specifically mention the names of the Tantra Yuktis, but he found out the examples in sutras themselves. Like this, several texts can be seen from this perspective, from fresh perspective, because as you mentioned in the lecture, new studies. Similarly, new studies can happen from this area also. And interested in our website, IKS.UOH.ac.in, wherein we have published something with regard to Bharati Sundana Paddhati, and 1 or 2 theses are also happen in our department. So what I is, yes, it is not at concept level, application level. We have been working texts like Maya and others forward. They can explore further for the benefit of the society, because you are the torch bearers of this wonderful Indian legacy and intellectual heritage. And Suraj also, I know him, doing his PhD in Kaladi. Yes, he also talked about Vararuchi. Interestingly, the 3 types of systems you mentioned, Katapayadi, Bhuta Sankhya, and mythological calculations. What was very interesting is, especially from Naraniyam that you have mentioned, sir, Ayur Arogya Saukhyam.
No, that is Kalidina Sankhya.
Yes, sir. Kaliyuga Sankhya. So I was just curiously Googled after you mentioned this. I heard about this, but I was not sure about what is the exact date. And one article mentioned that it is 17,12,210 days from the start of Kali Yuga that has been authored. So precisely on 8th of December 1586.
And that is the correct calculation.
So wonderfully, it is encrypted. Encrypted over there.
All our traditional knowledges are available in our Google, and even AI also supplying all these things. Gemini.
Exactly. Because the science is another face of God.
Yeah, surely.
Veda
It is like that.
Shastra and Vijnanam Etas Sarvam Janardhanat, as mentioned in Vishnu Sahasranama.
Yeah.
God is giving all this technology also.
In different forms.
Different forms. And you rightly mentioned you were talking about interdisciplinary studies. Mentioned Bhartrihari, Prajna Vivekan Labhate. And I recall the wonderful quote by Shishruta, much before Bhartrihari spoken about this. Ekam Shastra Madhyano So in the name of I replace so such a way, I think this interdisciplinarity is there because there is a paraspara purakatvam is there between Shastras. Upajivika bhava is there between the Shastras. We have been interdisciplinary from ages. As we also rightly mentioned, because of the English education, Macaulay Benitza has totally ruptured the backbone of Indian education system. Sanskrit was removed from the curriculum. Deliberate attempt happened because of which now we are again going back to the roots, so that we call it as interdisciplinary. But we have been interdisciplinary for ages together. I think we must realize this fact. Fortunately or unfortunately, something happened for 200 to 400 years. And yes, now we are going back to roots with the support from the government of India. I am very happy to inform you, sir. Probably you are also aware that many IITs have been working in this direction by starting IKS centers. IKS project sponsored by Government of India have been sponsoring centers, have been sponsoring projects, and also they are giving internships. Several things are happening in the market. Such a way, there is a hope to revive the ancient Indian intellectual legacy and heritage. Definitely, the future is in the hands of the next generation. And your lecture definitely instigated this curiosity and motivation in the exercise, I believe strongly. With these observations, I once again thank you very much for this wonderful blessing to all of us. Thank you very much. Mahan Pramodaha.
एवं महता सन्तोषेण एतत् कृतम्
सन्तोष धन्यवादः
स्मर्यते मया यदा तत्र NMM मध्ये तत्र मीटिंग मध्ये तत्र भवतः सान्निध्यं आसीत् अस्मिन् समये भवतः दर्शनमपि तत्र जातं
स्वयं देवदत्तः
इति एवं प्रत्यभिज्ञा जायते
भवताम् आशिषा तदानीं प्राप्तानि
अस्तु धन्योऽस्मि
नमस्कारः नमस्कारः Over to you, Ashwati. Thank you.
Thank you, sir. Thank you, Prasad sir, for your remarks. Now I invite Achyutananda Mishra sir, Department of Hindi, Sri Shankaracharya University of Sanskrit, Kalari, for his brief remarks. Over to you, sir.
Thank you, Ashwati. First of all, I'd like to thank Professor Muraleemadhavan for such a wonderful talk, and he spoke in length that our ancient tradition and Kerala knowledge base. And Professor Prasad has spoken in length what the Professor Muraleemadhavan has spoken. So I am not going to repeat all these things, but I want to add just one or two things. That why we are talking Indian knowledge system today. So the question is that we are finding a crisis today, and to resolve this crisis, we are looking back. Now the question is that, as Professor Prasad said, that last 300 or 400 years, I don't find myself totally in agreement with that, because what I remember that in 1910 or 20s, India has a glorious physics picture. I remember Professor Satin S.N. Bose, Chandrasekhar, Meghna Saha, all these are spectacular. So this knowledge system breaks between last 100 years, if you say. Professor Muraleemadhavan rightly spoke that the colonial picture is one of the main culprit. But it is not just one culprit. Last 1,000 years, how we have approached to the whole world, that is also one question. Because you see, everything, we accept everything, but we should accept that industrial revolution did not take place in India. This is also a truth. This is pre-colonial time. So we have to accept this.
Yeah.
I just like to put one more thing, sir. Pardon me if I say something in other way. That whenever we should approach the Indian knowledge system, we should go critically. If we don't move there critically, then it should be a kind of monologue, not the dialogue. For example, you rightly spoke about Brahmagupta. But what I remember that before Brahmagupta, I think maybe 500 or 600 years before, there was Alexandra, hero of Alexandra, and he found that heroes first, and he found the area of triangle as under root s into s minus a, s minus b, s minus c. That knowledge system. So I think whenever we spoke of knowledge system at a particular nation or something, we put the X on the universality of the knowledge. So we should say that there is an Indian knowledge system, but that should exist in a coexistence should be there. That Brahmagupta take something from here there, we gave something to others. That circulation of knowledge is basically a knowledge system. If it is stopped to, if it is totally confined to a particular country, then how can it be possible? Similarly, if we talk about that zero is by Aryabhatta, I remember Babylonians has first give the idea of the zero. The idea of zero was there in Aryabhatta, but it was rightly predicted by the Persians. So that continuity of knowledge is there. It should not be said that it is only in the one country or one place or one place. It should not be that. I think we should always, whenever we talk of Indian knowledge system, we should parallelly we should always talk of the coexistence and the traveling of the knowledge. That otherwise we are not able to understand how Aryabhatta was able to find, how Newton, before Newton, thousands of people have sit below the tree. Why Newton find? So that the pressure, time pressure, the social pressure, the way the knowledge travels, all this makes the knowledge system. So I think we should talk in a very collective way. Then we should reach, or we should understand the knowledge system. That came in my mind. But I really congratulate you for such a wonderful and enlightening discussion. Thanks a lot, and thanks to everyone.
Thank you, sir. Thank you for your time, for your words. Thank you. Before moving to the concluding section, I would like to remind you in the chat box, I shared the mail ID, the other questions. You can message to us through the mail. Now, we have now come to the concluding part of today's session. I invite Krishna Sri, research scholar, Department of Sanskrit Studies, University of Hyderabad, to propose the vote of thanks.
Namaste. On behalf of the Department of Sanskrit Studies, University of Hyderabad and Sri Shankaracharya University of Sanskrit Gallery, it is my privilege to extend the vote of thanks for today's enriching session of the Tadvidyasambhāṣā lecture series. Today's lecture on revisiting Indian knowledge system, new studies in Medieval School of Astronomy and Mathematics of Kerala, reminds us that as the world increasingly looks towards Bharat to rediscover valuable knowledge traditions, the contributions of Indian mathematics remains a source of inspiration and scholarly interest. Among these, the achievements of the Kerala school occupies a distinguished position, demonstrating the depth, originality, and scientific excellence of India's intellectual heritage. First and foremost, I express my heartfelt gratitude to Mahāmahopādhyāya, Professor P.C. Muraleemadhavan sir, for sharing his profound scholarship and valuable insights with us. Your lucid presentation has not only enhanced our
understanding of Kerala school, but also inspired us to engage more deeply with India's rich intellectual heritage. I extend my sincere thanks to Professor K. Yamuna ma'am, head of Department of Vyakarana, Sri Shankaracharya University of Sanskrit, for her warm words of welcome and continued encouragement of academic collaborations. My respectful gratitude goes to Professor Jyeṣṭhadeva Prasad sir, Head Department of Sanskrit Studies, University of Hyderabad, and Professor Achyutananda Mishra sir, Department of Hindi, Sri Shankaracharya University of Sanskrit, for their valuable remarks and constant support to this lecture series. My sincere appreciation goes to the Professor Kaveri Jadhav ma'am, Professor Vedanidhi sir, Dr. Sisa Thomas, Honorable Vice Chancellor of Sri Shankaracharya University of Sanskrit, and the distinguished faculty members of the university, Dr. R.D. Sunil Kumar, Head Department of Sanskrit Vyakarana, Professor Muthulakshmi ma'am, former Prof, Vice Chancellor of Sri Shankaracharya University of Sanskrit, Kaladi, the faculty members of the Department of Sanskrit Vyakarana and Department of Hindi. Also, I am giving my thanks to K.T. Madhavan sir, Dr. Gayatri Devi ma'am, Dr. Benani Basista, and the research scholars, the students, and all the participants who joined us this evening and contributed to the success of this section through their keen interest and active participation. I would also like to extend my special thanks to those who possess thoughtful questions and actively engage in this discussion. I would also like to thank Ms. Maya for introducing our distinguished speaker and Ms. Ashwati for gracefully conducting today's program as the host. And a special word of thanks to Mr. Subhashish, whose unwearying technical support and dedicated efforts for ensuring the seamless and successful content for the lecture and the YouTube live stream also. I also acknowledge the dedicated efforts of the organizing team of both institutions whose hard work behind the scene made this program possible. Thank you. Thank you all for your presence and participation. We look forward to meeting you again in the forthcoming sections of Tadvidyasambhāṣā lecture series. Thank you and good evening. Sorry, sir, I think you have to unmute, sir.
Okay, Professor Yamuna, Professor Prasad, and so many distinguished persons have attended the program, as from I understood from the vote of thanks, including our Vice Chancellor of Sri Shankaracharya University, Dr. Sisa Thomas. And I am very grateful to all the scholars, those who attended the program. There are so many limitations were there simply because that the area which I have to deal was so vast and equally important also. So which I will leave and which I have to receive, and this was a big problem for me. But anyway, I could give what we call agachulugena, as you say in Sanskrit. You take a drop of water in the hand and then taste it and see that the entire sea is salty. So like that, we can realize the significance and the seriousness and the lofty what we call the contributions of Kerala in mathematics, astronomy, and other fields. Thank you once again.
Thank you very much, sir. Sir, we will talk about marks separately. I totally agree with you. And Jyeṣṭhadeva Samadadam Samo Manam Janam. What you say from where? So Anobhadra, let the noble thoughts from all parts of the universe, we say.
Yes.
Yes. You, but I was in a different perspective. I was talking. Otherwise, I totally agree with you. Thank you for your remarks.
Okay. Thank you. Thank you.